Okay, so here we have another example of a rational function to graph. C of x equals 2x squared minus 5x minus 3. I'm not sure if that thing will factor. Let's see. Maybe a 2x here and then an x here. And I think if we have the minus 3 here and the plus 1 here. All right, let's see. 2x squared minus 6x plus 1x. All right, I like that. Minus 3. Okay, I like that. All over x squared plus 1. But y'all, x squared plus 1 is the sum of two squares. It is prime. It does not factor. Okay? That might be good to know. So when we are looking at our function to graph, we can either look at the original or the factored form. Okay? Yeah, I would like to make that not so big, but I can't without just messing with everything. All right. Well, time to go through, and we're going to do our steps here. Ooh, that's too thick. I'm having a tough time with the technology. Get it together. All right. First of all, y-intercept is going to be the value where x is equal to 0. So evaluate c at 0. I kind of like to do that in this form here because we've got the term 2 times 0 squared, which is 0, minus 5 times 0, which is 0, and then that's a minus 3 all over 0 squared plus 1. So you can see we've got a negative 3 over a positive 1, which is negative 3. All right, we got a y-intercept at 0, negative 3. There it is. Next, x-intercept. Okay, x-intercepts are going to occur where this numerator, or this form of the numerator, is equal to 0. When that whole fraction takes on a value of 0, that is just where the numerator is equal to 0. So we're going to solve the equation, and let me go ahead and put it in factored form. Set that numerator equal to 0, and solve for x. So we've got 2x plus 1 equals 0, and x minus 3 equals 0. Subtract 1, and then divide by 2. So we're going to get one value of negative 1/2. Add 3 to both sides, and so 3. There's going to be two x-intercepts on this thing. One of them is at negative 1/2. The other one is at 3. So I can tell you right now we're not going to have symmetry about that y-axis. No way. All right. Let's see. The third thing, vertical asymptotes. Vertical asymptotes are going to occur where the denominator is equal to 0. Now, y'all, that x squared plus 1, when you find where this thing is undefined, that's where we're going to have vertical asymptotes or holes in the graph. When we go to solve this by subtracting 1 from both sides, and then take the square root of both sides, not forgetting the plus or minus, we're going to get some non-reals. X is equal to positive or negative I. No, that's not going to happen. We are going to have no vertical asymptotes. That can occur. All right? No vertical asymptotes. All right, are we going to have a horizontal or slant asymptote? Horizontal or slant? Okay, well, let's look at the degree of the numerator versus the degree of the denominator. I kind of like to look at that over here in this form. The degree of the numerator is 2. The degree of the denominator is the same, 2. Okay, both of these are x squareds. And so we are going to have a horizontal asymptote at the line y is equal to the ratio of the lead coefficients. Okay, so you see it's going to be y equals 2 over 1. Those are the ratio of the lead coefficients, the coefficients of the x squared terms. And so we're going to have a horizontal asymptote at y equals 2. So let me come along here and let me dash in that horizontal asymptote at y equals 2. All right, the next thing we're going to see is if that horizontal asymptote, does it cross? Does our function cross the horizontal asymptote? That's the next thing to see. And that is this function, I'm going to clean this up in just a minute. Does that function there ever take on a value of 2? Well, let's see. We're going to solve the equation 2x squared minus 5x minus 3 over x squared plus 1. Is that ever going to be equal to 2? And I got the 2 from right there for my horizontal asymptote. Okay, let's do a little bit of algebra and solve and see if it's going to cross. Okay, first thing I'm going to do is multiply both sides by x squared plus 1. Okay, when I multiply both sides by x squared plus 1, over here it would reduce. Okay, and so let me get a little bit more room here. And so I would be solving 2x squared minus 5x minus 3 equals 2x squared plus 2. Now, when I subtract 2x squared from both sides, those terms are going to fall out, but I'm left with negative 5x minus 3 equals 2. And I'm going to have a solution to this. Add 3 to both sides. So I have negative 5x equals positive 5. 2 plus 3 is 5. Divide both sides by negative 5. So when x is equal to negative 1, this thing, that's an exclamation point. I guess I'm excited about it. Okay, this thing is going to cross my horizontal asymptote at an x value of negative 1. That corresponds to a y value of 2. All right? So at negative 1, 2, put a point on your graph and know that it crosses. Okay? So I don't exactly know how this works, but I do know over here it's going to approach but not cross our horizontal asymptote there. Here it's going to come down here somehow, cross my y-intercept there, come up and cross my x-intercept here, and then jump across my horizontal asymptote at the point we just found, and then go back down to y equals 2. Now what I may want to do is pick out some points to verify this so that I can get a little bit more accurate of a graph, but I think that's pretty much what it's going to do. Okay? Symmetry, I'm not messing with symmetry. No, thank you. Okay? So let me go ahead and say what I'm going to do here is I'm going to focus my work on plotting some more points. Okay? Let me clean some stuff up, and I think you can either plug your points into either one of these, but I think I'm going to be plugging those into my original equation. That might be a little bit easier. I don't know. Okay? So I'm going to pick out some x values, and I'm going to find the corresponding y or c of x values to get some points. Okay, so what would I like to know that I don't know yet? Maybe, for example, what happens when x is, I'd like to do a little something over here, like what happens when x is a negative 2? I'm going to check that out. What happens when x is a negative 2? Okay. What happens when x is maybe, let me go 1. When x is 1, I would kind of like to know, like, how far am I supposed to be down here? Okay. And then you can pick out some more if you want to. But let me do that little chicken scratch over here when I'm going to evaluate my c function at negative 2. I'm going along here, and everywhere I have an x, I'm going to put in a negative 2. So I've got 2 times. Let me do this in my head with a negative 2 squared is a positive 4. Then I've got minus 5 times a negative 2, and then it says minus 3 in the numerator. In the denominator, negative 2 squared is positive 4 plus 1. All right, let's crunch all that and see what we got. We actually have 2 times 4 is 8. Negative 5 times negative 2 is a positive 10. Minus 3 over 4 plus 1 is 5. So let's see, I've got 18 minus 3, which is 15 over 5. 15 divided by 5 is 3. Hey, so this goes negative 2, 3. All right, I can be a little bit more confident in my little, you jump up to there and then go back down. If I wanted to make sure, like I could also do like negative 7. I could let x be equal to negative 7. And I'll tell you right now, I will get 2 point something. Okay, now I don't know like what the decimal part of that is, but if you wanted to crunch it, you could. Okay, so I could kind of help verify this point, that behavior. All right, a little bit too carried away over there. All right, now let me calculate my C function when x is 1. So C at 1 is 2 times 1 squared is 1 minus 5 times 1 is just 5. So minus 5 minus 3 all over 1 squared is 1 plus 1. So let's see, that comes out to be 2 minus 5, which is negative 3, minus 3 more is a negative 6 over 1 plus 1 is 2. Negative 6 divided by 2 is negative 3. So when x is 1, y is negative 3. Hey, I did pretty good. I don't mind telling you. 1, negative 3. Good. And so what I think happens here as we kind of complete our graph and fill this in, I think it comes down here and it crosses, and then it probably has like a little relative min somewhere in between there. A little relative minimum value, does a little dip. And then it's going to take on here, and it's going to come along here and not cross on this side. Just get closer and closer to 2 there. Now again, I think if you wanted to say, like, let x be equal to positive 7, what you would get is you would get something pretty close to 2, but it would be like on the side of 1.9 something or 1.8 something. All right, so you could do some more points if you wanted to. And so kind of to draw a little better graph of our function, maybe along those lines, this is the graph of my c of x function, and you can write its equation if you would like. Okay, so that one was kind of funky looking. A lot going on there. I think these are kind of fun, but you do have to know all of your steps. You do have to know how to find your y-intercepts and x-intercepts, all the asymptotes, whether it crosses or not, because that tells a story. If you didn't know that it crossed, if you forgot that step, you'd just be like coming up here and you'd just be going, like that, and that's not right. Okay? It's got to do that little funky jumping up business. Okay.